Okay, let's get started. So today I'm going to be talking about how to improve code quality with static analysis. Exciting stuff. I am Joe Purcell. I've been part of the PHP community since 2003. Currently, I'm at Digital Bridge in Chicago. We focus on making a difference for mid-sized companies in the Midwest who find B2B e-commerce strategic for their company. We are hiring, so if I do a good job, look me up. Who are you? My hope is that you care about code quality. You have some understanding of the challenges that we face when we're working on projects or we're maintaining a technical platform. You might be a developer who wants to improve their craft, or you're working with a team of developers who you're looking for ways to, as a team, quantify and improve the quality of the work that you do. You might be a project manager and you want to have better visibility over what do developers mean when we talk about good code. Or you might be a leader and a leader in your organization, and you too want to have better visibility over, when do we actually need to refactor? When do we need to throw a part of the system away and rewrite it? The takeaway today is going to be an understanding what static analysis is, and we'll talk about how to tie static analysis into your development process. But before we get there, let's start with some stories. Who uses spell checker when they're writing an email? You probably do because your browser has one built in. Typically, we don't trust when we see something like this. This is a sign that says private parking. All others will be towed. Towed, the animal, not actually towing your car. But as humans, we're pretty forgiving, right? Like we see T-O-A-D, and we know they probably meant toad. If they meant toad as in the animal, it was probably just a joke. So as humans, we're pretty forgiving. Typoglycemia. This is a legend about you can take the letters in between the first and last letter of a word, scramble them, and we as humans can still understand it. So I typed a sentence here, who needs a spell checker? And I scrambled the letters, and you can probably read it and actually comprehend what I meant when I said that. However, computers are not so forgiving. Let's go back to 1962, when NASA was launching its first interplanetary vehicle, Mariner 1. Cost about $18.5 million at the time. Today, that'd be about $150 million. Rocket is launching off, and they notice the guidance system is not responding properly to the commands being given to it. Within 5 minutes of launch, they self-destructed the vehicle for preventing the risk of the rocket actually landing in an inhabited area. In the aftermath, what they found, and you may have heard of this, is this was the most expensive hyphen in history. What happened was when they were, this is 1962, when they were transcribing the mathematical equation and writing the software for this, the transcriber missed an overbar. The overbar signified using a smooth value versus the raw values. What happened was they were sending commands to guide the missile, and it was overcorrecting, providing erratic behavior. Let's look at another example. This is as recent as 2012. This bit of code here, you don't even need to know programming, and you could ask the question, why is goto fail here twice? That seems odd, right? So in 2012, this code was released in iOS and OS X. What this ended up causing is the ability for a man-in-the-middle attack on any SSL or TLS connection on iOS device. Basically, that meant you could listen in or hijack that connection. This was not fixed until February of 2014, 17 months after it was introduced. This was something that could have been caught by static analysis. One quick side note on that, a number of compilers will complain about duplicated code or code that wouldn't be reached. PHP, however, as we know, as those who are in the PHP community, PHP doesn't warn you of a whole lot before execution. So, point for today, if you're not using static analysis, you're wasting time. You're spending time doing back and forth on code review over code style. You might be spending time doing bug resolution for obvious problems. That might be dead code, like the go-to-fail bug. Might be typos. You might have a mistyped variable, for example. Or you're wasting time in the grind on poor code. That is, you're dealing with highly complex, highly coupled code. You want to make a little change and you find out, oh, I have to make the same change in 10 other files. Or I want to change this interface and I have to change 30 classes. Frankly, you don't have time for this in most cases. So today we're going to go over what is static analysis. We're going to go over some specific examples of what static analysis can find and what the significance of these different checks are. And lastly, we'll look at a process around how to tie that into your development process through continuous inspection. Static analysis is similar to spell checking. It's anything that you can learn from the code without executing it. You don't have to, if you're spell checking a document, it could be a legal document, it could be a blog post, you don't have to understand the content to know that TEH is probably the misspelling of the word the. The same applies to code. Let's go back to go-to-fail and pretend that that was written in PHP and pretend this was written in Drupal. If we were to apply PHP mess detector and PHP code sniffer, these are two static analysis tools, we would have found at least these three violations. We would have found that the method it utilizes a go-to statement per PHP mess detector. You should use other control statements instead. And it would have found Drupal, part of Drupal's coding standard is to not use inline control structures. So at the end of the line where it says if, you should have a curly bracket if you're following Drupal's code standards. And lastly, the third line there, the second go-to fail, would have thrown a violation of it's incorrectly indented. There should have been 4 spaces instead of 6. So how exactly does static analysis work? On a basic level, it's just reading a file off disk and looking for a pattern. You can do this in your editor, so you can configure, if you're using Sublime or PHP Storm, you can configure it to look for these types of checks. And as we'll see later, you can tie it into your continuous integration process. There's a lot of tools for this. I'm listing some of the more common ones here, but in the further reading section on my slides, you'll see some resources for some more tooling. Some of the work, if you're using Drupal Coder, that is a code style standard built on PHP Code Sniffer. There's mess detector, which is detecting dead code, checks for complexity. There's copy and paste detector, which is checking, okay, you have 10 controllers and they're all repeating these same 10 lines of code. That's an instance where you might want to refactor. And there's many more, and there's some for JavaScript, there's some Sass linters, etc. So let's try this out. Let's look at a couple of these static analysis checks. Global variable access. If you've been a developer very long, you know that you're forbidden from using global variables unless needed. So one of the static analysis checks is looking for access to those globals. We find this line of code here, and what static analysis is going to do for you, you don't have to read the code. It's going to trigger an error on this line, or trigger a warning on this line. You don't have to go digging for those. Here's another example. Unused variable or a method parameter. Take a look at the second line here. The variable entity is assigned, but it's never used. I'm cutting off some of the lines of the method here, but this variable is never used. We'll go into more detail later as to why this is a problem, but very basic level, these are the types of spell checks, if you will, that a static analysis tool is going to do. What's the point of these? If it stinks, change it. I'm beckoning the wisdom of Kent Beck, who's a well-known software development leader, thought leader. And in the book Refactoring, he refers to his grandmother who, when talking about when do you know to change a diaper of a baby diaper? Well, when it stinks. Same principle applies to code. If you're looking through code and you notice a pattern or you see something that isn't quite right, change it. That's the principle that we're looking at here. So let's look in a little more detail. But before we do, I want to go over some generic categories or characteristics of these checks that apply and kind of categorize or give qualitative categorization of what is good code. So I've identified a few here, and I'm going to go through each one. And as we go through some of these examples, we're going to refer back to these sort of, characteristics of good code. And anytime we see one of those checks, we'll think, oh, okay, so readability, for example. I, as a developer, if I can't pick up your code and read and understand it within a reasonable amount of time, I'm wasting time. Maintainability. So you have a module that you're developing, 3 years down the road. How easy is it going to be to apply bug fixes or apply updates to it? Extensibility. Let's say you want to build out a new feature on your site. How easy is that going to be to do? Security. How vulnerable is it to malicious users? If you're using, user-provided input and you're not sanitizing it, that's a risk. Testability. How easily can we write a test to verify its behavior? If it's a private method, for example, and there's no public method exposed to access that, then it's untestable. And lastly, correctness. So bugs and technical debt. It's not enough to just have code that meets the business requirements. There is this qualitative aspect of correctness that is around how efficiently it does that. Are you using solid design patterns, for example? So first example here, we already saw this. This is the global variable access. And for each of these code examples, we're going to talk about smells. We're going to talk about, okay, here's the things that we see as being of good quality, and here's why these lines of code don't match that. So with testability, in this example, the globals config, you don't have control over that global state. So you may run into a situation where you have a flaky test because another part of the code, another part of the system is setting this global variable. Security, you're not sanitizing input here. So can you verify that when this cache value is being read that nothing malicious could be going on? And extensibility, there's no abstraction possible, right? This is a primitive value that's being assigned from a global variable. Unused variable, we already saw this one. Problem here is, you look at this code, why is getEntity being called and assigned to entity? There's no documentation that tells you as much, and you don't know if there's some secondary effect happening that is actually needed in some obscure way for further lines down in this code. And correctness, usually if you have an undefined or unused variable or method parameter, that's usually the sign of a bug. Common case is if you misspell a variable, that's going to get flagged as an unused variable, even though PHP is going to execute it correctly. Here's another example, dead code. dead code would be the same check that would have flagged for go to fail. Dead code is during execution, will this method or will these lines of code, can they even be executed? So here's an example of a method that I found, and it's a private method, but there's no other method on the class that's actually calling this. So readability, you ask the question, why is this method even here? Is it cruft, or did we forget to call this method somewhere? Testability, you can't test it because it's a private method. You can use some fancy reflection, but practically speaking, it's very hard to test. Correctness, if you have a private method that's never getting used, it's either cruft or it's a bug. Number of public methods. So you define a class. In this case, this is entity type. There are 69 public methods on this class. Extensibility is a problem. Also, correctness, probably violating single responsibility principle, which says when you create a class, the class should do one thing. There are some cases when this is desired if you want to consolidate complexity, but in general, when we're developing software, this, if you see a flag for number of public methods, that's an indication that, hey, maybe this class is actually doing two different things, and you can find ways to abstract or separate the responsibilities. Use of statics. Drupal is not very good at this. This is the workspace controller, and notice the line where it says load multiple. You'll see similar lines to this. This is a static method call. The problem here is there's no way to stub the return value of load multiple. So you'll want to address this on a functional test level. This basically means you cannot unit test this method without doing some kind of reflection. Also, extensibility. You can't replace workspace type with a subclass. There are cases where this might be desired if you want to control extensibility. If there is a case where you can foresee there never being a subclass of this, in the case of like the Drupal class, for example. But in general, this is a check that says, hey, of the things we're considering as good quality code, this does not apply. Missing doc comment. This is the replicator manager, and there's a method on it called update. This has since then been fixed, but looking at this method, there's no documentation that explains what update is doing. If you had stumbled upon this, you would immediately ask the question, why is this just a wrapper for do replication, right? And you would have to look elsewhere in the code for an explanation. Extensibility, if you have to change this class, if you can't figure out what this method is supposed to be doing, then you don't know the author's intent. So you may introduce a critical bug by modifying this class. Missing documentation should be considered a critical bug. In-path complexity or cyclomatic complexity, these are fancy words for there's a lot of stuff going on in this method. This is a method that I pulled out and I eliminated the lines that weren't a for each loop or an if statement, etc. Brief explanation, cyclomatic complexity is go through the method and count how many control statements there are. The more control statements, the more complex, right? If you have a for loop statement and there's 3 nested if statements, that is more complex than for each that calls a method, for example. In-path complexity is similar in that it's trying to quantify complexity, but it checks for the number of independent paths through a method or through lines of code. In this case here, this method has a cyclomatic complexity of 15 and an in-path complexity of 420. The problem here is you're not going to remember all 420 paths of execution through this code when you're trying to debug it. Try debugging this method in, an hour. Correctness, if you have highly complex code, this might be an indication that you need to separate some of the logic out into another class. That said, there are some cases where you have some really complex operations to handle, and it makes more sense to, group all of that into one method. But again, going back to, this is what we say is good quality code. This is one of the indications of that, and it may be an indicator that, hey, we should refactor this method. This is one of my favorites, efferent and afferent coupling. Essentially what this means, efferent is I have a class and this class knows about 10 other classes. Afferent is I have a class and there's 10 other classes that know about me. In this case, we're looking at Multi-Version Manager, and Multi-Version Manager knows about 15 other classes. This is a common case for manager classes. But we have the problem of extensibility is hard. If you have high coupling, it's hard to change. Also, try writing a unit test for this. You have to write a test double for each one of these other classes. That's a lot of work. Also, you might be violating single responsibility principle. There might be essentially if you see highly coupled code, that might be an indication that there's a design pattern that we could apply here. So we've gone through a number of examples, very specific examples looking at why those checks are valuable. Now we're going to look at, okay, you're on board, you see the value of these automated spell checks. How do I start? How do I tie this into my development project process? First, the examples I'm going to work with are from CodeClimate. CodeClimate is a static analysis platform. By a platform, I mean CodeClimate aggregates these various tools. So it has PHP mess detector, as PHP code sniffer. It has some other ones like ESLint, for example. And it's free for open source projects with a caveat on GitHub. There are some alternatives. You could configure these tools yourself, but I'll explain later why I think CodeClimate is the best option if you're wanting to get started and you don't want to spend a lot of effort going through configuration and trying to find a way to manage the output. CodeClimate does a great job of providing some good visuals. We'll first look at how to configure CodeClimate on GitHub, the same repository where these slides are. I've posted some example configurations for Drupal 7 and Drupal 8, whether it's a module, core, contrib, or a project. The CodeClimate YAML, this is the one that is needed by CodeClimate. The CodeClimate YAML basically tells CodeClimate, hey, here's the static analysis engines or tools that I want to use. In this case, we're specifying PHP mess detector and PHP code sniffer. And the second thing it says is, here's the directories to look at. In this case, we're, a caveat here, and the next slide I'm going to show mess detector. Mess detector, you can use some of its config out of the box, but I don't think all of it applies very well to Drupal. So I'm including a PHP mess detector config here, as you see the .php md.xml. The rating section, this is important. Basically what this is saying is when CodeClimate is going to compute a GPA, which we'll talk about more later, the rating section says, here are the directories to give ratings for. So in this case, we're only providing ratings for the custom modules on our Drupal project. Also, this is a D8 example. So if you're on a D7 project, that's going to look a little different. Go to the Git repository that I've made for this on GitHub and take a look at some of the other examples. The last part of this config file are the exclude paths. So we're excluding configuration, we're excluding core, profile, sites, themes, etc. A big improvement that could be made here would be to configure this for themes, but for the purpose of demonstration, we're just looking at contrib modules. As promised, PHP mess detector. So PHP mess detector is pretty opinionated. I have done my best to take the mess detector configuration and create one that I think makes pretty good sense for Drupal. These are not necessarily checks that are Drupal coding standards, but in my opinion would be generally considered checks for good quality code. You can find the full file on the GitHub repo. So now we are at a point where we have code climate configured and we want to use it on our project. There are two general ways that I see code climate or a static analysis tool being used. One is using it in a development workflow that is continual inspection. Basically, this means if you're using a continuous integration system like Travis or maybe Circle CI or even Jenkins, development workflow means with every pull request or every patch, you are running automated tests. In addition to that, you're running static analysis. And that's going to be, that feedback is going to go back to the person who created it as well as the rest of the development team. So development workflow is going to be one approach. The other is a code audit. Code audits could apply if you hire some people who you can devote to solely devoted to improving code quality. It could apply if you're doing a retrospective. Hey, the estimates, in the last sprint took twice as would be expected. Are there ways that we can improve code quality? Code audit might be a good way to do that. So, development workflow. Basically what this looks like is I'm a developer, I commit and push my code. That code goes up to GitHub or wherever my repository is. A automated process gets kicked off. The tests run. In addition to your automated tests, static analysis runs. Then there's some kind of feedback. Maybe you have this tied into HipChat or Slack or an email, and I get notification as the committer that the build has failed. And this is an indication that I need to revise my code. If it succeeds, passes on to code review and it's merged. What this looks like is, and this example is 18F. They're using Code Climate on some of their open source projects. This is what it looks like when it's green. If I'm a reviewer and I see this, I know two things. I know that all tests have passed, and I know that of the checks that we've made for our static analysis tools, whatever we've configured, I know that there were no violations introduced by this pull request. Awesome. I don't even have to open the View Changes tab and look through to find any code style violations, because Code Climate just did that for me. Now, this is what it looks like if it failed. I can click on details and see more about what exactly Code Climate found. In this case, it's going to list the specific issues, and you can, on the right, it gives you a way to look at complexity or style violations that are only introduced by this pull request, which is really useful. Now let's talk about GPA. What's interesting here is the GPA, the way that I think about it is a GPA is basically, think of it as how many violations per line of code are there, and it's normalized. So if you have like one code style violation and you have 10,000 files with hundreds of thousands of lines of code, your GPA might be really high. Whereas if you have one violation in one file, GPA is going to be much lower because the ratio is different. That's basically what a GPA is, and we'll talk about later some anti-patterns for how to use GPA. But basically what I can use here is I see the issues introduced, I see how it impacts GPA, and I can drill down and kind of narrow down to the different types of checks. This is really useful. I don't have to look through the code to find these errors. I can go directly here. All right, the second way I could see static analysis being used on a project, we just went over, ties into development workflow, clean as you go. The other might be a code audit. So you might have planned refactoring. Say you have a 14-month project. Month 6, you may want to take some time to go back in and refactor. Doing static analysis might give you some indication of where you want to refactor. Another might be sprint retrospectives. Going back to the example of, hey, last sprint, we noticed estimates took way longer than expected. Why was that? Can these static analysis tools give us any indication with a clearer picture than the code is bad? phpmetrics.org has a tool that is really cool. Basically what it does is it analyzes your code and gives you various metrics, and you can create really fun graphs. I used it to create a graph for Drupal 8. This is a little dated now, but what it means is the size of the circle is the volume of the file, or the volume of the class, basically how many lines of code. The x-axis on the bottom is efferent coupling. Efferent coupling is, I'm a class and I know about 10 other classes, or I am using or calling methods on 15 other classes, etc. The vertical axis, the y-axis, is cyclomatic complexity. Remember, this is, go through the method, count how many control statements there are. What I find interesting after running this is how many people have used Entity API? How many of you had to maybe try to extend or modify the behavior of Entity API? This right here is a graph that quantifies that difficulty, either through high coupling or high complexity. We see those bubbles, we know those classes. We know the classes that are hard to extend right here. And I don't even have to have read the code to know that these classes are going to be hard to extend. They're going to be hard to maintain. So a graph like this might be a good way for you to, take a project and, maybe you inherited a legacy system. You can use this as a method or a tool to talk about, not just among developers, but project managers. Hey, when I have to change something in Entity API and I give an estimate, that might be a high-risk estimate because we're dealing with complex code. We're dealing with highly complex code. Now let's talk about what not to do, right? So static analysis, setting it up, you can actually, with Code Climate, you can just go and submit your repository and it'll run, which is great. But there's a problem. Static analysis is only as good as it's configured to be. So you might run it on Code Climate, and I'm actually a little frustrated by the documentation because they don't call this out. You need to configure Code Climate. Don't just run your project on Code Climate. Go and configure it. You have to create a Code Climate YAML and define exactly what you want to check. Static analysis is only as good as it's configured to be. So the reason why you can't just run it out of the box is it's going to run on every file in the system. So there might be some really odd cases where, I don't know, say you've included some third-party library and that's committed to your repository, for example. Out of the box, that's going to be run. That's going to show up in your analysis. Also, speaking of typos, static analysis is not a replacement for your brain. Some indicators are okay. Some complexity is okay. There are cases where you will need to access a global variable, such as pulling, if you're using mod PHP, you need to pull the request information. And also, it's this definition of, okay, these static analysis checks are kind of our quantified version of quality code, don't take that as a strict thing. Like, what I love about Code Climate is you can define a GPA, and you can essentially say what your tolerance level is for these, certain checks. If you're shooting for a GPA of 4, you're probably doing it wrong. Unless of course, I'm not discouraging you from that. I'm just saying that there are cases where you may want that indication, but some of those indications may be okay. Use good judgment. You know more than the static analysis tool of what good code is. Static analysis tool is there to support that. Don't compare GPAs of projects that use different configurations. So let's say we have 2 modules, and one is checking for static calls, and the other is not. One has a GPA of 3, the other has a GPA of 4. Don't compare the two. They have different configurations. The GPA is going to be computed then in a different way. This is why the checks that you do need to have some level of curation and some level of understanding. So if someone takes your code and say, hey, we've run this really cool static analyzer that inspects for security, and they say, oh, there's all these violations in your code. Double check and verify that those checks are in fact indicators of bad code. You know better than the tool. Don't avoid static analysis because there's too much to tackle. This is also one reason I like Code Climate, because you can set up Code Climate, it'll run once. On that pull request, it's going to show all the errors in your whole code base. But what's great, merge that, and the next pull request that comes up, it's only going to show violations for that pull request. So my advice here is, cleaning your code is hard work. Static analysis makes that easier. See this tool as a way to assist your efforts of cleaning code. And don't only run static analysis locally. Some people, have their editors configured. Awesome, well done, thank you. Some people have pre-commit hooks. Awesome, well done, thank you. But don't only run static analysis locally. They should be shared among your team, among your project managers, among anyone else who is, putting dollars in to maintain, or maybe they're buying this code from you. Share that. Let that be public information, just in the same way as a test failure is made public and shared among your team. If you've never read Clean Code by Robert Martin, highly recommend it. Very good book. One of the diagrams he shows is he's talking about clean code. He's talking about, what is the cost for not having clean code? What does that look like? And this graph he uses as one way to show the effect of owning a mess, or owning, one way to phrase it would be to own a code base that has a lot of static analysis violations. That's one, that would be an example. So over time, your productivity goes down. This is because code has entropy. As you develop and evolve a system, things change. What was the correct implementation 3 weeks ago may no longer be the correct implementation. If you change it and you don't go back to clean it up, it's going to be harder and harder for you to implement new features or do bug fixes. And it's not just productivity that's impacted. One interesting thing is there was a research done on Linux kernel and Windows Server. Linux kernel and Windows Server are both using static analysis, and they found that there's a 50 to 60% correlation with static analysis checks and bug reports, user end bug reports that came back. And here's the savings. Just as we saw in the pull request examples, if you have static analysis, you're not wasting time looking for code style. That's already done. You can just point to code climate. You can point to wherever your reports are and say, hey, go fix these things. It'll even say the line of code where the violation was introduced. You're not worrying about obvious bugs or typos. Go to fail will not happen. It also means you can clean as you go. If you've been involved on the Drupal issue queue, you know if you've been zealous and wanted to go and fix all the things, your hand has probably been slapped. This is because when you do that, you are likely causing conflicts with 10 other issues that are open that are trying to change the same lines of code as you. What this does is it allows you to clean as you go. Per patch or per pull request, it'll show you exactly the violations that were introduced in that pull request or patch. And you know the parts that are hard to change. If you're using static analysis tools, you're going to have some indication of, okay, here are the classes that are highly coupled. Here are the classes where there's a lot of complexity. If you're looking for a core initiative, or you're looking for, we have a growing number of bugs on our project. Look for the problematic areas. Focus on those. Static analysis can give you an indication of where you might want to improve. So what's next? I think the initial next step is agreeing on static analysis config for D7, D8, core, contrib, and projects. As I mentioned, so we already have code style standards for Drupal, but we don't have, for example, a generally accepted PHP mess detector check. What is Drupal's acceptance of numbers of lines of code in a file? Or what is the accepted standard for how complex can a method be? Can I use 30 use statements in my class? Are those things accepted? Well, can we create a, not just code style, but looking at, some complexity metrics, or even some security sniffs? Can we define those things as a community? This is kind of a pitch to Code Climate. So right now, Code Climate only supports GitHub, but one of their focus is being free for open source. I think it would be awesome if they supported Drupal.org, because we know that everything on there is GPL. Start using static analysis on core and contrib. So after we've defined, here's our checks that we're all going to agree to. Maybe we could add those to core and contrib, if that's using Code Climate or using our own tooling, what have you. This is the ticket number out there right now. Go and make a comment. Add GPAs to compare contrib modules. Right now, we base our judgment of contrib modules based on, I know 3 people have used this module and they say it's really good. Or, this module has 3,000 downloads, this one only has 500. We are currently using metrics to compare modules that don't get at some of these very specific code quality aspects. Take 2 modules, how many code style violations are there? Which one is better documented? If you're having static analysis checks for documentation, that's going to come out in your GPA. Complexity, that's another example. Take 2 modules, which one is throwing, tons of code into single methods versus, exercising solid design patterns and, has loosely coupled, highly testable code. GPA will at least hint at that. Imagine if every PHP or Drupal vulnerability gets a sniff for it. If you look at the Ruby Handbrake project, they're already doing that. Can we do that? as the PHP community or Drupal community. Imagine a day when we have automatic code quality spike tickets created on Drupal.org or our own projects, whether that's through a vulnerability that's introduced. You write a sniff, say the Drupal security team writes a sniff for it. That gets pushed out with our static analysis tool that runs and automatically creates tickets on every module that has this vulnerability. Awesome, that'd be great. Or maybe we have, GPA drops below a certain threshold. Ticket is created to improve that quality. If the Drupal community agreed on a GPA, we could do something like that. We could have a generally accepted standard for code style violations or complexity per line of code. And we can use these checks in autocorrect. Right now, we can use PHP code beautifier and fixer, PHP CBF. Some of you may be using this tool not knowing it. It's configured in some editors like PHP Storm. You can also do it in Sublime. But imagine it can do, imagine where that project could go. And lastly, one of the things that's pretty cool about Code Climate, I mentioned it's a platform. I also mentioned it's open source. You can write your own engines. So if we wanted to write a Drupal engine that had all of the code style standard checks or PHP mess detector checks, or even our own sniffs, we could create one and have that run on Code Climate. So you've heard about static analysis. I've told you about, here's some general characteristics of good code, and we've stepped through, here are some examples of checks that tie back to those qualitative aspects of code. You know this, you need to speak for the code. If you know Zendoodles, Andrea Soper, we gave some talks last year around technical pollution, insights from the Lorax. She introduced the great analogy of the Lorax. And in the story, the trees are an environment is being polluted, it's being devastated, and one of the things the Lorax says is the trees have no tongues, right? The code also does not have a voice. It has no one who can, the code can't complain about itself. It's Friday afternoon, you're trying to get a release out, and you merge a whole bunch of really bad code. The code isn't going to complain. That may complain in a bug report later, but usually you're willing to take that risk. You have the responsibility to prevent Drupal preventing your project from having the next go-to fail. Stop wasting your time. Clean up your code. Thank you. Come to the sprints tomorrow. Slides are online. If you want any help setting up Code Climate or even working with PHP mess detector or any of the static analysis tools, let me know. You can find me on Twitter. Happy to help. My last slide are some further references and reading. So, any questions? Okay. Thank you.